This fifth exercise presents a model of a timber frame construction made using 3D printing. The aim is to facilitate understanding of the structural principles and, thanks to the larger printed joints, we can clearly understand, observe, and analyze the geometry and logic of the joints in the timber frame. The exercise begins with the design of the exercise using CAD tools and showing the complete model of the structure and its different components. In this software, it is possible to see both the construction of the structure and the enlarged joints for timber construction, as well as to understand how each piece forms part of a coherent structural system before its physical manufacture. Next, we see the 3D printing process of the modular structure and joints. Once printed, they are cleaned and prepared to ensure a good fit. This phase allows us to understand how digital manufacturing can accurately reproduce traditional construction systems and joints commonly used in wood construction. Before assembly, the different elements are presented. The scale model allows us to understand the general organization of the structure, while the enlarged joints serve to study how the joints between parts are resolved in a real construction. Separating the two scales helps to distinguish between the overall shape of the system and the construction details. With the help of any type of strong or contact adhesive, it is possible to obtain the fully assembled structure. And with the enlarged joints or connections, the student can relate the overall framework to these joints. Although these are not part of the assembly, they allow us to understand how loads would be transmitted and how stability is ensured in a real wooden construction. This exercise shows how a 3D printed modular model can facilitate understanding of the construction. The design of the model allows for an understanding of the overall organization of the structure and the relationship between its components, while the enlarged details help to analyze the logic of the joints and the structural behavior without the complexity of a real construction site. The combination of scale, modularity, and digital manufacturing makes the model a clear and effective tool for constructive learning. Understanding the structure is understanding the building. From scale model to construction detail, Wenus.